All right, we've got 10 seconds until Advent of Code day 15. This will put us at about 10 days left. Let's see what we got. Oh, lanternfish. Oh, look, lanternfish. Does anybody else remember lanternfish? No? Okay. I wonder if the past year's solution actually still works. Okay, so we've got more robot movement. I actually really like the robot movement problems because they make for really good visualizations, or at least fun visualizations to make. So we end up with a map here. The circles look like blocks. No, the circles are boxes. At is the robot, O or 0 is the box, and hash is a wall. So we've got a number of different things here. And then we've got a bunch of moves, up, down, left, right, that the robot will attempt to make in order. New lines within the move sequence should be ignored. The lanternfish would like to know the sum of all boxes' GPS coordinates after the robot finishes moving. We've got a smaller example and a larger example, so we could have two tests here, potentially. We've got edges of the map, so we've got effectively just the interiors really matter. Distance of 1 from top edge, so this is a 0. 0, 1, 2, 3, 4. Okay. I feel like we cut out the walls in general because we kind of don't need them, but we could keep them. Keeping them is probably easier in general. What happens when a robot hits a box? If there are any boxes in the way, the robot will also attempt to push those boxes. However, if this action would cause the robot or a box to move into a wall, nothing moves. So it looks like it can push multiple boxes. Is that shown in the example? Yeah, it can push any line of boxes. All right, well, I guess we get these examples in. We start writing our tests. Here's a smaller example, so let's get that in first. So there's the smaller example, and then we've got, I guess the larger example is this one. Let's call this like test process small. Actually, the rules aren't different, so we don't actually need to do that. I'm actually going to do this instead. So we're going to use RS test today, which is actually fun because we haven't used it yet. So let's drop this in here. There's a number of cases. We're only going to need 2 cases, and we need to put case in front of each of our arguments here. So in this case, we'll have case input and case result. And both of these can be string slices because that's what we will end up with the process. Or rather, it'll work out just fine if we do that. So this is the first, and this is the second. And the answers for these are 2028 and 10,092. So this one is 2028, and this one is 10,092. Input comes from there. We process the input. We check against the result. We don't care about Fibonacci test. We care about our test process here. Okay, so I think that works. So we're using RS test and using the RS test macro, attribute macro, whatever, to set up a couple of cases. In this case, we can use the case attribute macro to set up an input and an output. And we can do that again here. And then we can write one test function that takes these 2 cases, and we assert that the result is equal to the process. We haven't had a lot of opportunity to use table-based tests so far, or we haven't needed it. So you can see here that we've got case 1 is failing, which makes sense. So we probably want to write our parser first. And maybe we put together a hash map. So I think we'll build up a hash map of these IVEC2s to objects. Objects are going to be wall, box, or robot. I'm going to derive debug on this enum. And then the GPS coordinates are going to be 0 based on the walls. If we see a wall, that is going to get logged. If we see a box, that's going to get logged. If we see the robot, that's going to get logged. And then we're going to try to skip any dots. So I feel like my approach to this is going to be somewhat similar to the other day. So I pulled in some of the parsing code from the other day. I'll leave this as a to-do for the moment. So nom, locate, glam, we've used them in previous videos. I'm not going to explain what they are. We've got to be able to parse hashes, dots, new lines, O's, I guess. Actually, I think that's an O because I think I have my font set to do slashes circles. I think I'll put an alt in here and do cars, which I'm not typing correctly, but so it goes. So the alt parser gives us or allows us to take a tuple and parse one of the values out And because we're doing this position thing like we did the other day, we're getting all the positions for all these IVEC2s. We don't really want this 2-digit. We want each of these to be mapped. We actually don't care about the values. So we actually don't even need to map it in general. So if we use the value combinator, I reversed the positions of these. Then this is a vec or IVEC2s of objects. And we don't have clone on these values for the object. So to use the value parser, we do need clone because we'll be creating copies of them. So we have this object position that takes our span type, which is our new type written in this file. This is a located span from nomlocate that takes a string slice. We get the position, the columns from that input. Then we try to parse out a wall, a box, or a robot. This is either going to be a hash, an O, or an at. And then we return positions of those. So this parses one of these objects, which means that down here we still need to do the rest of them. So we can do preceded and we can do is a dot. I think that actually fails for the parsing though. Yeah, is a fails because is a needs to succeed. So we could just throw an opt on this. So fundamentally it won't matter what happens to that. And then lines becomes a vec of IVEC2s. So we end up with what? Lines dot iter dot flatten dot collect hash map. Maybe we don't even need to specify because the type inference can take care of this. We can probably into iter here instead of itering because we're kind of just consuming the whole thing, which makes our reference type to an owned type. And then we get our hash map. So we kind of consume all of this into a hash map, return that. We are also going to need the rest of the parsing. So if we do a debug here for the input, we can see what's left, which will be like a new line and then all of the arrow characters, or a double new line, I guess, and the arrow characters. So we can do kind of the same thing we did up top like this, except instead of 3 of them, we need 4 of them. And I think I'm going to name these direction, and I'll name them like north, south, east, west. We haven't written this, so don't worry about not knowing where this comes from because it comes from nowhere at the moment. So north, south, east, west, west, east, south, north. And we say let input directions equals preceded. And I'm just going to throw like tuple, or I guess space. We can just do space 1. I think we need multi-space, but we'll try space 1. Right, so preceded by some space, a bunch of arrows. And then when we do our object up here, I'm just going to copy this, paste it. And actually, now that I think about it, we could actually just directly translate those into IVECs instead of creating a new one. So like IVEC to north is negative y. So we'll do negative y here. And then y. And then east is x. And west is neg x. So now we actually have the values that we need to go in for those directions, which makes directions a vec of IVEC2s. So all of our commands to do. So this is a hash map, and our other return is a vec of IVEC2s then. And you can see our type inference fail right there because now it's not the same type. But if we put our tuple here correctly, then that should get cleaned up. And just like I thought, space 1 only does regular spaces. So I think we need multi-space. So there's space and multi-space here. Space is 1 or more spaces in tabs, whereas multi-space is 1 or more spaces, tabs, carriage returns, and line feeds. So we actually need multi-space here because we just want to eat all types of space, not just non-line endings. And actually, it's pretty straightforward to see that we are failing in that way because the code is space, so the parser is space, the error code is space. And then the fragment that was left over is new line, which is all white space, but it's all new line white space. So we end up with map and directions, right? Which we can just print out here and see. So we've got a whole bunch of directions here and a whole bunch of locations. Probably want to do a cursory check that we're doing something correct. So 6, 9 should be a wall. 0, 1, 2, 3, 4, 5, 6, 7. Is this the first test or the second test? This is case 2. So if this is case 2, then we need to look at case 2. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not really a useful one. So let's try something like 7, 2. So this is 2, 0, 1, 2, 3, 4, 5, 6, 7 is a box. I think I'm pretty confident in that because that is multiple new lines. We already know that we get the bottom. So I think we're good there, actually. So while we're doing this, we might want to work on one of the tests and not the other. So if we do cargo run next test, what are we, day 15, part 1, we can see the test IDs here. So it's part 1 tests, test, process, case 1, and that should run only the first one. So 1 test ran, 0 passed. So now our output is definitely for case 1. Filtering is really, really nice. We could also write a function like we did yesterday to like pretty print out this box, which might be useful just because that is how the initial state output is given today. But we do need to iterate over the map basically and make a bunch of changes. So I feel like I'm not sure that there's really any shortcuts here. There entirely might be, but I think I'm going to go with the naive approach to start with, and we can always optimize later. So we end up with like mute map, right? And then for direction in directions, right? Direction being an IVEC2. We kind of need the current robot's position, but the current robot's position also matters in the map. So maybe we do something silly to start and do map.find or map.iter.find. This will be like position object, and this will be object equals object robot. And this has to work. So we'll dot expect a robot, and we have an IVEC2 and an object. The object doesn't really matter to us. We only really need the IVEC2. There is an issue here with equality, so we'll have to derive partial equality, and I'll derive eq as well, eq being more of a marker. Oh, I just realized I'm not watching the test failure there. So no implementation for double shared reference equals, so we can just match the references on either side and we'll get that. So we've got case 1, we've got directions, we've got the robot. Now we need to push the robot into the boxes. So I think we start off with maybe the easy version. So let next equals map.get robot.0 plus direction. So let sum next equals this else. I guess if there's nothing next, it would be outside the bounds, and thus we should actually panic here. And we need to pass a shared reference in on this math. So we're doing a for loop here because I'm planning on kind of just like replacing this map, but we'll see. So we can match on object here, or not capital O object, but next, which is an object. If it's a wall, then I think we just continue. If it's a box, we need to either check all the objects until wall or check all objects until, I guess, wall or space. And then if it's the robot, then we've messed up. Should never see a second robot. So I'm going to use unreachable there. I think I'm going to do unreachable here too, because those should never happen. We are missing a thing here. Maybe we have an extra. I think we have an extra. No next tile already? That shouldn't happen, right? Well, let's check. Oh, right. Okay, if there is no next tile in that direction, then the robot needs to move because it's empty. I don't know why I thought this was unreachable. So it's a little awkward because a hash map is kind of a data structure where we would need to remove keys for this. I do want to be able to access them by position, but that does mean that we need like map dot. I think map is already mutable, right? Yeah, there it is. We could potentially use extract if, but then we have to touch everything. So we're just going to do remove. Well, yeah, we're going to remove the robot's position, right? Robot.0, which I think is an issue. We do need to continue here, and there's going to be a shared reference issue for this, I think. Yeah. Map.remove, mutable borrow occurs here. We could do .0.clone, and then we don't need to .0 here because we know we have the robot. And then this needs to be a reference. Bot is going to be that object, which we know is there, right? Expect robot to exist when removing. And then map dot insert robot plus direction and the object. And that should start moving through. So if we hit a wall, we just continue because we can't do anything, go on to the next one. If we get nothing, then bot can move. If we have something, then we need to match it against a wall or a box. If it's a wall, then we just do nothing and continue. If it's a box, then we need to do this thing where we like chain in the same direction and find all of them. So if next is a box, then we have the robot, we have the position, right? We actually need this to stick around, I think. So let's make this next position. And then this is here, and this goes here. So we start off with the next position. So we have the robot and we have the next one. I think actually we probably want the robot position here too, right? So we've got robot, we've got next, and then while map.get next position plus direction, right? While next is equal to this thing, this has to be sum actually. This has to be a reference. This has to be items. How do we get the last items? Items.iter.last is probably the easiest way to do that. Items.push this. So we're doing our math twice, but that's fine. This needs to be inside of a paren. Direction is probably a reference, right? Cannot add ivec2 to option ivec2 plus direction. ivec2 is last. Last has to exist. So we'll unwrap that. And last has to exist because of the way we've set this problem up. So after we fill that, then we basically have to do this match again. So it's this again, which I think I'm just going to copy in because it's not that much logic. Move this comment up. So check all objects until wall or space. I guess we could be more specific because this will only ever be a box, right? While some object box map get, right? So while we're still getting boxes, we stick them into this items because we're already in box. We know these have to be boxes. Makes it a little bit more clear what's happening here. So items.push the direction or like the position anyway. So we end up with map.get the same thing, right? This item's last situation, right? So let sum next equals map.get this thing. If nothing, then the entire bot and entire item stack can move, in which case we basically just need to move two things. We need to take the first item out of items, which is the bot, move it to the second, and then add one to the end. Is that accurate? No. I think we don't just push once, we push all the way, right? Is this one is this move by one or move by everywhere? Because I actually only coded the bot to move by one. Initial state, move left, do nothing, move up, go up. Moving right only moves one. Moving right only moves one. Yeah, so bot only moves one. The whole thing only moves one position at a time, if you will. So bot and next item can move. So we only really need those two, but we do need the final position. So we have robot, which we can just remove. So actually, I don't think we need robot here because we're not doing anything special with it. Then we've removed the bot. We're going to insert the bot at the next position, but we probably want to remove the next position first. Map.remove item 0. I guess technically item 0 and the last one could be the same too, because we could have an immediate space, which means that we probably want to do items next here, right? So let mute it equals items.iter. We have to have this one. Oh, it.next, not items.next. We have to have this one. So next has to exist. And I guess we do it up here so that we can keep it around. Next item location, right? Shared reference to an IVAC2, so we can just do that. And then we have basically our iterator of items. We've already popped one off, so it's possible this could be empty. So we have to match on that. The next item location has already been removed, so we can actually reuse that here and insert the bot. And then match it.next and do the arms here. And the question is, if it's none, then we map.insert next item location plus direction, right? With next. I don't know why I named that next. And then if we do have one, I'll call this location, I guess. I guess this is it.last, right? And then if we do have a last item, then we need to map.insert location next, which is a shared reference. So we need to dereference it, I think. Yeah. And then what do we end up with? We end up with something. I guess we debug map down here. I think we need to visualize this to make sure that it's actually what we need. But we could also skip the visualization and hope that we get the answers here, because I don't think we get steps for the next one anyway. So if we get the answer right here, we know our logic is right. If we don't, then we are all the worse off. So the box has a distance of 1 from the top edge and 4 from that, resulting in a GPS coordinate of 100 times 1 plus 4. So it's 100 times y plus x. So map.iter.filter, position doesn't matter, object does. Object equals box, right? And then we map over this with the position, and we do 100 times pos.y plus pos.x, and then we dot sum this. This sum goes into a U size, probably, maybe not. There's almost certainly a references issue here, so double reference. And then this is okay result.toString. I don't know why I capitalized like the S in toString all the time. Okay, so we've got 2028 and 1116. So we're getting the wrong answer, which means our logic is somewhat wrong. So I think we have to display it because that's really our only option. So we have to do this, and we have to. Can we take anything from yesterday in terms of writing this out? So we did a part 2, right? This has a debug function in it, debug grid. This happens to just be a vec, but map size is something we're going to have to pass in. This is going to be a hash map of IVEC2 and objects. This is not robots. This is objects that we need map size to be able to actually render it. So we'll call that an IVEC2. We'll bring in standard format. We also need standard format right. This will be objects, or objects can't be in multiple places. So we can objects.get instead, right? So objects.get IVEC2 new xy, and this will be some object or none. In none, we're going to do just a dot. In some, we are going to do the object. Object doesn't have a display implementation, but we can implement that. Standard format display, get this. We write into F with the match on self. We fill, nope, we don't fill apparently. We save, and we need our string literal here, and this then fills match arms. Wall is hash, box is O, robot is at. And we should be able to take debug grid as long as we have the map size. I don't know that we have the map size. So let's do a quick let map size. Actually, if we don't have the map size, we can just calculate it in the debug, right? Let map size equals something. We'll do IVEC2 new, and this will be map.iter.find or .map position. I guess this is keys, right? Keys position pos.x.max. I think that's an option, so we unwrap, and then map.keys.map pos.y max unwrap. And what is wrong with that? Oh, we called this objects, not map. And then we have debug grid and for direction in directions. Let's do like dot take 4. Let's debug grid map, and we'll print line this because we formatted this into a string, which I think needs to take the shared reference, right? Into iter take 4. What's wrong with debug grid? Debug grid is a result. We're going to unwrap that, assuming it'll work. So we end up with this for the starter. Initial state looks right. Interesting that we aren't actually rendering out those extra hashes. So I want to go into here and do dot dot equals. Make sure we get that extra hash around the outside. Overall, that looks good to me. Let's do this print line at the end of this, right? Because we have the original, and then we want to get to here. And we end up with nothing. What's the issue? Does this never run? 1, 2, 3, 4 runs 4 times. I guess we continue in all of them, right? So we need to put this before our continues. Unfortunate that we need to put that everywhere. Probably could have avoided that. Might not even need continue, honestly. So we chose debug for that. It's the wrong choice. We really want print line. So now we have initial, next, 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 next. How many do we have to compare against? Initial, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that all of them? We could do a whole bunch here. Oh, maybe it is all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not quite. A lot of them, not all of them. So let's grab this, dump this into a new one, and we get this in a split right so that they can actually compare. So far, so good. Let's do 1, 2. So far, so good. This one on the right is wrong. It looks like we have 2 to the right and we eat 1 and don't replace it. That's our issue. So if we've got items, right? This is our next position. We've got the robot, we've got the box, and we've got the next box, right? So items is first box, I think, right? Next position is robot plus direction, actually. So that's the one after the robot, which is the box in this case. So if it's a box, then this is a box. While this equals the last position in items plus the direction, then we push that into the items. So here, let's just do items in general, actually. So we know where our issue is, right? Move to the right here, and then we eat. So 3-1 is in the items list, and then 4-1 and 5-1 are in the items list, which makes sense. And we end up with just 5-1 that gets moved. 0, 1, 2, 3, 4-1, 5-1, and then 5-1. So the question is, we have all the items. We're correctly pulling out the first item. Are we correctly inserting the last item? I don't think so. One of these two, right? If we're inserting location, then that's that. If we are inserting, I don't think next item location is right there. Yeah, inserting 5-1 here, we should be inserting 6-1 here. So next item location is not what we want. Next item location is bot, right? Next item location, oh, wait, so 4-1, 5-1, right? Inserting 5-1 is wrong, but we have the right numbers here. So it.last location, we do get inserting. So location is wrong. Why is location wrong? Because this also needs to be added. And then we get one more than our test because I think probably the robot is counted. No. Why do we get one more? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Looks like the robot should be eating that bottom one. No, we're not done there yet. Oh, because it's, yeah. Because I did take. We don't want to take. We want to just run now. Save that. Computer's feeling a little laggy. Probably have too much uptime on this computer. It looks like our test passed there. Looks like our second one might have failed. Case 2 fails. That's not good. So we have a passing test and a failing test. Don't love that because we don't have any debugging for, maybe I missed something. Maybe I didn't parse enough. Are these actually new lines? Yeah, they are. Okay. I don't know why that makes it easier to copy paste, but that's got to be our issue. I guess I forgot about the new lines. I don't know. Preceded by multi-space, then all of this, but actually this is in need of going in here. Let's do separated list line ending here instead, because there are line endings. Output changed. Let's do separated list 1, line ending alt is not what we need. Preceded multi-space, separated list 1, many 1 needs to be here still. And we need to directions.iter.flatten.collect into iter because we're just going to consume everything. Okay, cargo run, day 15, bin part 1. Let's not debug all this stuff out. I'm not going to lie, I do absolutely get exhausted by needing to pay attention to every little detail like this. I do wish the input was just the input in the same way that it was. I do recognize that that was my mistake, but we got the answer. Yeah. We basically have this grid to manage and these directions to manage. And this grid is made up of hard static walls as well as some boxes that can move around and a robot. We have to move the robot one square at a time, and everything moves one square at a time. So if this goes to the left here and pushes this box, that's only going to move one square forward. If it was one layer up and it was moving left, it would also only move one square forward. So we got to write a parser for all these locations and then parse all of these. We chose to parse all of the instructions, like all of the arrows, as IVEC2s directly. So we did these with the consts for neg y, x, and neg x, which was useful for us because we just got to scan over these and use them. The parser includes some extra white space, but only sometimes. So in the separation between the grid and the rest of the stuff, it is preceded by a number of spaces. And then only if there are multiple lines do we have to separate this by line endings. And then we do many alternate choices of these characters. So we take that and we just flatten that. We probably could have written this as an iterator and collected directly or something like that. But I actually made a mistake in the parser to start with, and I didn't handle those extra new lines. I know the problem said that they're broken up into new lines for like copy and pasting purposes, and it explicitly calls out new lines within the move sequence should be ignored, so that's on me. But they're broken into multiple lines just to make copy pasting easier. Doesn't make sense because there are other really long lines in the input in other days. So object position uses nom-locate to get those positions. We're parsing into wall, box, and robot with the characters. We implemented display for each of these objects. So whenever we print these out, they print as hash, o, or at. We use nom-locate, so we have to do the located span with our string slice. We wrote a debug grid again. In this case, we wrote it to pull the maximum values for x and y out of the map and then iterate over those and print out the values. We print it out to a string because previously we've chosen to written that to a file, but we didn't necessarily want to do that. So we printed it out a bunch instead. Once we have that map, which we make mutable, and the directions, we iterate over all the directions. We find the robot for each iteration. The next position is the robot plus the direction we have to move in, which is already in IVEC2, so they just add together. If there isn't something on the next tile, then the robot just moves there directly. And we do that by removing it from the map and reinserting it. If there is something, that's this next, then we match on what that is. If it's a wall, then we don't move. If it's a robot, then we have to match on this because it's in the enum, but it's not a variant that we're going to find a second one of. Like, we're not going to find a second robot. So we use the unreachable macro there. And then this is a box, which we start off with the first box position while we are fetching items out of the map in the direction that we need to go. So we iterate and get the last item in items, which is going to have one all the time. So we unwrap here. We add that to the direction. We try to get it out of the map. If it's there and it's a box, then we push that direction into the vec, and this will stop when it stops finding boxes. We then tried to get the next to last position, or not the next to last, the position after the last box, or rather, we use the position after the last box in the row or the column to get that object. If there isn't an object there, then we can move everything forward, which we do in this. If there is an object there, we should actually be testing this to see if it's a wall. But we've already gone through all the boxes, so it can't be a box. It's not going to be a robot, so it's always going to be a wall. And that's due to other checks. So it's kind of like implicitly a wall, which I don't really like. So if I was going to refactor this, I would probably try to refactor that out. At least I don't love the way that this is like here, but we don't use it. So if the bot and the chain of boxes can move to the next, we remove the bot from the map. We start iterating over each of the items. We get the first out of the items list because there always has to be that first one because we kicked off the boxes. We remove that and keep it in next. Then we insert the bot into the position we just removed. So we're basically taking the bot, removing it from the map. We're taking the next item next to the bot, removing it from the map, moving the bot into the position that was previously filled by the box. And then we take the very last item, if there is one, and we put it right after the end of the last box. So instead of shifting all of the boxes forward, we take the first one and we move it to the end. And now we've got to do part 2. We've got to do another warehouse, similar layout, key difference. Everything except the robot is twice as wide. The robot's list of movements don't change. To get the wider warehouse's map, start with your original map, and for each tile, make the following changes. If the tile is hash, the new map contains hash hash. If the tile is a box, the new map contains box. If the tile is dot, the new map contains dot dot. If the tile is at, the new map contains at dot. So this will produce a new warehouse map that is twice as wide with wide boxes that are represented by square brackets. Robot doesn't change size. Larger example now looks like this. Because boxes are twice as wide, but the robot is still the same size and speed, boxes can be aligned such that they directly push 2 other boxes at once. After appropriately resizing the map, the robot would push around these boxes as follows. This warehouse also uses GPS. Then to the closest edge. So I think we can just score the left brackets. Like we can skip over all the right brackets when we're doing the scoring. Well, this just feels like a bunch more edge cases. So basically the same code, but so I guess now we have to move everything. So we can't take the shortcut we took in part 1, where we kind of take the first item and move it to the last item. We have to move everything forward, and everything has 2 positions effectively. Well, at least this will be fun to visualize at some point. So basically the edge cases here become the robot can be pushing up or down on either side of the box, and thus if this one pushes up, it also pushes this one up, which means that this position and these 2 also need to be free. So we need to check a lot more places for potential walls or blocks. I can't really think of an easy way to adjust this to be any easier other than listing out all of the edge cases, checking all of the gaps, and then just keep doing that, I guess. So I guess step 1 is to expand the walls and the boxes. We need to deal with effectively a completely different set of characters when we're doing our processing. We have the smaller grid from the original parse. We don't, unfortunately, get the answer for the smaller box. I don't know if this is actually listing out all of the moves or not. So I think I'm just going to comment out the smaller test for the moment. Or rather, I guess we only run the smaller test to check against the positions because we have the positions for the smaller test. And then the bigger test is what we run to actually see if we wrote it correctly. I feel like I want to reverse the way these are stored. So I don't particularly love it, but I do think the easiest path forward is to expand the string slice beforehand. So we can do that really easily for expansion, like input cars map. Then we have this. Oh, I just thought of another edge case. So maybe we do this in a way where we go outward from the robot for detection about whether we can go forward, and then just try to make all the moves. We could write a box struct and then impl something that looks into the map ahead of it instead of writing it out manually. That doesn't really help us though. I kind of really can't think of a better way to do this. So our objects need to expand into wall left, or not wall left, box left, box right, which starts out by not sounding too bad, but I think the edge cases are kind of killer here. All right, so we've got wall, box left, box right, box left, box right, and then there's no other like actual changes, right? Everything else is just regular. We do have multiple locations where now we have to figure out like, oh, it's a box. Is it box left or is it box right? So if we try to remember our logic, maybe we print the debug map first and comment everything out just to make sure we've parsed this correctly and set it up at all. I am going to choose to pass everything through here. It's a little bit annoying that we have to pass through characters here. Looks like parse failed because of multi-space, which is interesting. We changed the input, so let's make sure that we're using the modified input here. And is this the right output is the question. Looks right to me. So we at least have the right content here. And that went through our parser. So now we have walls, left and right, box, parts, and more. So we have to special case moving horizontally and moving vertically. Moving horizontally, we just skip one and then include that direction. So let's do an uncomment of all the code we commented out. Let's not print any debugs here. Let's do find the robot. If there's nothing, then we can move. That doesn't change. Otherwise, we have a wall. We'll do, we have box left and box right, during which we have to special case. We can't approach a box left from the right. We can approach it from top and bottom. So let's do something like if next position dot x equals 0, vertical movement, else horizontal movement. And here we know that we're always moving west because we can't hit this if we're coming from, oh, sorry, we're always moving east. We're always moving east because we can't hit left from the right-hand side. So if next position dot x equals 0, that means we're doing vertical movement. If it doesn't equal 0, then it's negative. We know that for sure. So same kind of thing would go for box right, and this is always moving west. So we can't separate things, right? So we get to do this still, I think, for horizontal movement only. Box doesn't exist. Let's get that comment in here too. So let's say fn horizontal does this stuff, and this is going to be map, which is going to be a mutable hash map of ivec2s and what's the other thing? Objects. Next position is an ivec2, which can't go inside of the hash map declaration. And then direction is also an ivec2. These can be shared references. They don't need to be shared references. This while loop gets a little trickier to write. I think I'm just going to leave those as owned because the rest of our code I think works on owned values. While sum box equals map get whatever. Items push. This will create our list going one way or the other. I think we can be a little sneaky here and do some object box left and some object box right. So while it's a box, little awkward way to write it, but lets us keep the logic we wrote before. So then we have items, which should be a list of box parts. This is all an issue because of this continue, I think. So I'm going to put a to do here. We're going to pass in the robot here too. So horizontal takes the map, mutable reference to the map, next position, direction, and robot, checks all the objects, puts them into that items vec. Next is always a wall. So if we have some, then it's not empty. Otherwise, we actually need to go through everything, including the bot, and remove them and move them one by one. We could go in the reverse direction as well, but so I think here then we add bot here. No, I think we do robot here, which lets us still hold here. So iter last plus direction. And then for item in items, this should give us an ivec2. We need to then remove the item. Maybe we don't actually need robot there. We need object robot here to start with, right? So we can just do this instead. So this was old bot. And then this doesn't need to be here because we're not going to use it in the iter like that because we've already removed it, right? So then we want to take the item, which we already have, so we don't need it. I'm going to name this item location. Item location is next item location here. So we have to move that logic up. For item location in items, let next equals remove item location. This is actually going to be last item equals remove. And we do our little swap here. So we have our last item, right? We need to insert that last item in the new place. So we do let item to insert equal last item. We have to remove that one and then move this one. Probably would have been easier if we did it in the other direction, honestly, now that I think about it. And then this is last item to insert because pulling an item into an empty slot is probably easier than keeping track of it like this. So we could have reverse ordered this, but then we would have also needed to start with the location before, which I think we could have done. And then we don't need last here, right? Let's see, for item in items, we get to the last item, right? We pop this into item to insert. We remove the last item, we insert the new one, and then we have to do one more insertion, which is absolutely last item. And how do we get the last location? I guess item still exists, right? Maybe not. What is the issue here? Let else. Right, this needs to continue. And that's this. And then we have this and this. So we only need one more after that. And what are we saying is our issue? Expected never found unit. To do insert last item. That's fine. Cannot continue outside of a loop. Oh, we're not looping. We're actually not looping and we're not returning. So I think we just return here. This removes and does what? Cannot assign twice to a mutable variable. What are we assigning to? Oh, last item is not mutable. Cool. And then we're still missing one horizontal and we're still using box somewhere. Oh, for the filter for the end. Yeah, cool. So I think that's just the box lefts for the score. And we need to have horizontal and call horizontal, and we want to iterate over this in a way that allows us to access it again. So we'll go to for in shared reference. What items.iter.last.unwrap gives us the location. So I think this works for horizontal, regardless of which direction we actually need. We need to pass in a mutable reference to that map here. We need to do this again for west. And then we need to handle north and south, which are the conditions that have the additional edge cases. What are the first movements for this? Okay, it expands and then it moves left. Okay, that's cool. Let's do that. Let's check out let's check out the smaller test for a moment, because this will just run a ton, right? And then we want to get our debugs back in here. So we'll get the first one, we'll get the move, and we'll uncomment anywhere else we had it. So that doesn't look right. Hang on. Oh, this is some random other. Oh, this is some random other input. It's not the original test input. Okay. So let's do this, and we'll no answer this because this test is never going to pass. So if we start with this and we move to the left and then we move vertically down, that moves it like that and down. So I think that's correct for horizontal. And then the issue is going to be this vertical move here. That's going to just chop this whole thing in half, right? Like this, and then this goes. I feel like I'm missing a print line here. This right before return, I think, is the right thing to do there. There we go. A little bit more visibility. We should see this happening here. This is the issue right here. This is the edge case. So we can't just push up for left and right, even though interestingly that does kind of work. We do have to push everything up here. So the answer for a vertical movement is going to be different because we need to fill that item slot with a bunch of different items. I can't think of a situation in which it would be an issue, but we're going to have to take care of the order here and move everything up once. So the horizontal movement is roughly the same thing we need to do for vertical, except that the way we do detection of the items is going to have to change. So this isn't just check all objects until we run into a wall or a space. We need to keep accumulating these objects successively until we hit a wall. And if we don't hit a wall, then we move everything up by one, or in the appropriate direction by one, I should say. So this items push here, this is the next position we want to go. We know we've hit a box, so this is either a left or a right item, right? So this needs to be called vertical as well. So if map.get next pause unwrap, because it has to be there. This is definitely a box. Actually, now that I think about it, it's definitely a box, but we need to, it would be probably nice to pass in which. We know if it's a box left or a box right when we call it, right? So it's going to be like vertical. And maybe we next here. Can we next here? I think we just matched on the actual value, right? So it doesn't. Oh, the other thing is that this doesn't take that yet. So vertical then is going to take a reference to an object. We can't do next because that's pulling from map for keeping the data around. And because we are pulling from map to keep the data around, we also want this exclusive reference. So we're just going to go with a new value here, which is totally fine. Oh, that is wrong. That's not what I meant to do. Vertical here is box right. So we know which one we're starting with now from this object. So let's match on that object. It's going to be neither of these. It'll either be left or right. If it's left, and this is going to be items, by the way. So let items equals this. If it's left, next pos is an IVEC2, and the right hand value is the right one to return. And then this is vec next pos plus IVEC2 neg x next pos. So we end up with this items that has the left and the right hand side of whatever box we're trying to move up or down. So items is now multiple items. I think we might need two vecs here. One to keep track of what we've already seen, and one to keep track of what we need to do next. And then this probably also needs to be a hash set, right? So we've got scene items, hash set, and next items. Next items gets filled by the first thing we give it. And then I guess while next items dot length or next items is empty, I always forget to do this. While next items is not empty, then next items dot iter. I guess we could into iter this too. It doesn't really matter. But we probably want to insert those into scene as well. Does it matter if we have multiple in scene? Probably not. But I don't think we can have multiple in scene. Not yet, anyway. So next items dot iter, right? Dot map. If we have anything, we need to check any space above it. If that space is a box, then we need to grab the second value. So for item in next items, check in direction. If box, or rather, if wall, don't move anything. If box, get other side. And we'll have let new items here equal a new vec. I guess we could do a hash set here because we'll be potentially filling this new items with multiple box sides of the same kind. So we check in the direction we need to go, right? Item is an IVEC2, so item plus direction. Match on map.get next position. If wall, return. Done, right? If wall, we can't do anything. If box left, get box right. If box right, get box left. Anything else, unreachable. If none, that's fine too. This needs to be a reference. Hash set needs to be IVEC2. Okay, so while our next items is not empty, we're going to take these new items, which is empty. For each of the next items that we need to iter over, we need to get the next position that it would need to go into. If that is a wall, we can't move anything and we return. If that is a box left or box right, then we need to get the box right or box left for that position, right? So we just did this up here, left, left and right. So this is left, or this is right and this is left. And these just go into here. So we need to actually insert both of them in that case, right? For item and next items, if it's a wall, we return. If it's because that'll return us from the vertical function. If it is a box left, we insert left and right. If it's a right, we insert right and left. If it's none, we don't do anything. We can just continue, really. And then when we are done with this, we have to take new items, make it next items, and move next items and make it scene items, right? So for item in next items, scene items dot insert item, and then next items equals new items dot. Can we build a vec from this? Right, vec IVEC2. Next items. I'm surprised we can't do a vec from a hash set. The if expression is missing a block after this condition. Okay, 169. Oh, this down here. Okay. This doesn't matter. This we can get rid of. This vec still needs to be constructed somehow. So we'll clear next items for item and new items, next items, push item. So overall, this should give us scene items and next items. So scene items should be full. And then this has to iterate over all of the scene items. So let's just do that and do a to do. It looks like there's some issues here. This has to be mutable if we're going to push into it. Move out of next items occurs in loop. Is it just in the wrong place? So new items gets reset at the top here, right? Yeah. So we're good there. Next items does not. Next items is here. It's mutable there. It's a vec of ivec2s. We use it here. We need to reference that, dereference that. Next item is borrowed here. Borrow later used here. Borrowed on 138 for item in next items. This has to happen outside of that loop. So that's good. And then we failed on the assertion. So we should be getting here and figuring out what that does. Are we ever making it to a vertical? We should be making it to a vertical here, technically. So we're hitting move here for direction and directions. Map over, get the robot, next position. If the bot can move, we just continue. So this is happening there. And then match next. We'll print line box left and box right. These are vertical, but we don't hit boxes because that hits the empty space. So left, right. Yeah. This hits a box left. It hits a box left? Should hit a box right, shouldn't it? Did I mess up? This turns into that. Box left is that. Box right is that. Yeah, box left is parsing as that. Box right is parsing as this. So we move to the... That's not box left, though. Yeah, those are all box rights. Oh, because I didn't write my debug log correctly is what happened there. Whoops. Starting to make mistakes this late into the game. So -1 0 -1. This hits box right. It should hit vertical. It doesn't hit vertical. So we're here. We hit box right and we hit horizontal. Why do we hit horizontal? 0 -1. Did I mess up my... If next position x equals 0, should I not be matching on next position? Next position is the robot plus the direction. So it would be robot. Oh, robot plus the direction. Yeah, we need to do just direction here. We just want to detect which direction we're going, horizontal or vertical. So now we actually don't move that when we get to it because we haven't written the logic to move it yet. So we are vertical here, which is good. Good. And now we have a bunch of scene items, which are 8, 3. We've got 3, 3, 4, 3, 4, 0, 1, 2, 3, 4. We should have 4 3s and 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. That looks right to me from a Y perspective. And then this should be 0, 1, 2, 3, 4, 5, 6, 7, 8. So 5, 6, 7, 8, and then 6, 7. So this is good. This is all of them. So we have all the scene items, and we know that we can move up because we never saw a wall, I think. So really all we need to do here is scene items dot sort by... Wait, scene items is a hash set, isn't it? Yeah, scene items is a hash set. So we need to turn this back into a vec if we're going to sort it. So let's just turn this into items. We'll do items sort by. This gives us 2 ivec2s. And then we need to know which direction we're going in vertically. So match, maybe if direction.y is greater than 0, do 1 and then do the other in the other case. These need to be references. So theoretically right? We just want to debug items. And this should be sorted by y value in the direction that we're trying to go. So maybe we should debug direction here too. So we're trying to go in the upward direction, negative. So I think we just need to reverse that because we need the first items to be the low ones because what we're going to do... No, we needed them to be the high ones. That was correct. We need it to be the opposite of the direction that we're going in. So we end up with going in -1, which means decreasing in height, which means going up, which means we need to operate. Actually, I had it right the other time. Oh, we need to move all the 3s up to 2s, and then we can move all the 4s. So this is the order. And then it's like for item in items map dot remove item dot unwrap, right? With a reference here. And then item is an IVEC2. Items, we don't need to debug out, so we don't get the use after move. We get an object here and a position, and we need to do item plus direction map.insert v, and we panic here, but really we're just done because this is a mutative function. So we're here, we go up, we move everything up, and then generally looks good. What it needs to go up one more time from here. So that's here, and then are we not processing the last one? Is that happening there? We're 618. I don't think we get an answer for this one either. So we're going to remove all of this stuff. Oh, we didn't move the robot, did we? Did we move the robot? I think we did. So this, I think the issue is actually we didn't move the robot here, right? We don't put the robot in the vertical set, do we? Scene items, robot. I think that's what we have to do. Robot has effectively already been seen. So that builds, that runs, and we end up with not being able to view the end again. But we have an issue up here, or we had an issue, right? So this moves up. We're not debug printing the vertical movement, so we should do that, right? Only debugging horizontal. So there we go. That's up there, and also this should go up. It goes up with that, doesn't move, and then moves to the left. Yeah, okay, so that's better. And then we don't get the answer for that one, unfortunately. We only get the answer for the big one. So we can only do the big one now, which I hope works, because not particularly fun to write this whole one. And then let's get rid of the print lines. Why did I do print lines instead of something else? I don't know. Let's do day 15 part 2 and hope it runs at all. Oh, there's another print line somewhere that we missed, or I missed. You're not writing code. You wrote your own code. Losing it. All right, let's put this in. We got a gold star. So the first time we tried to run the program, we got the right answer. Wonderful. It's been too long working on this problem. This didn't feel like a terribly hard problem from a mechanical perspective or a programming perspective. It was just like, okay, deal with the edge cases now. So in part 2, we have to expand the grid. So I chose to do that in the most simplest way possible and just map over the characters and expand them. Done. We wrote a slightly different parser and we kept the box sides separate. That was really the only difference in the parser. Then we go over all the directions. We find the robot like we did in part 1. If the map, the hash map, has an empty slot in the next position, the robot can just move there. If it's a wall, we have to continue it because it can't move. If it's a box left, we have to determine whether it's horizontal or vertical because we have slightly different movement conditions for those. If we move left and right, we can kind of just scoop everything up and then shift it. If we do top and bottom, we kind of have a different algorithm for how we have to find all of the box pieces. In either case, that happens and then we sum up at the end. So for horizontal, this is very much similar to what we did for part 1. We're just checking to see if we have box pieces. If we do have box pieces, then we push it in. And as long as we have box pieces, we can just keep kind of moving them to the appropriate direction, left or right. The horizontal function is written generically to operate with a direction. So we don't actually have to care. We just know that it's going horizontally. All basically the same logic. Remove from the map, insert into the next position, keep going, keep going, keep going. Same kind of thing for vertical. Vertical, we keep a couple of intermediary vecs here. We keep the items that we've already seen, which starts out to be the robot. We keep the items that we're going to process next, which in this case is going to be the left and right box pieces. While we have items to process, we are going to set a new hash set, iterate over the items to process, check the positions above them to see if they can move. If it's a wall, it can't move. If it's left and right box pieces, then we have to get both of them because we can't move half a box. And otherwise, we just iterate over those items and we push them in. Once we have all of those items, we kind of swap out these various vecs that were popping around, like the hash maps and stuff. So the items that are in next that we just processed get inserted into the scene hash set. This keeps our count of positions unique, which is important. We set next items, the ones we're going to process next, to an empty vec, push the next items in from the new items that we just created here. Then we collect all the items that we've seen after we do all that other processing. We sort them by their Y position according to the direction that we are moving in. So if we're moving up, we sort it one way. If we're moving down, we sort it the other way, so that our iterator here always iterates over them from the direction we're going extreme towards the robot. And we do the same thing. We just remove and insert. And that's it. TLDR. This was a long one for me today. Like I said, not mechanically intensive and not really like knowledge checking either. Just kind of you have to handle the edge cases and pay close attention, which of course I didn't pay attention close enough in part 1, and I actually missed a new line in the parser. If you've watched this long in the video, you know that. So hope you had a great day with this one. I actually do like the robot ones because they end up being interesting visualizations later. So hoping to visualize this one, maybe with Bevy ECS tile map, which just got published. And I'll see you in the next one. Have a great rest of your day.